Hey guys, let's get started with talking about the periodic table. So the periodic table is basically an organization of all of the ingredients that exist in the whole universe. So it's made up of elements, and elements are pure, which means that they aren't a mixture of anything. Of all the atoms of one particular element are all going to look the same. And so that's what I mean by it's pure. It's not like a compound, which is made of two or more elements combined. The way that we put together these elements, it's going to determine what it makes. So for example, there are certain elements that make up you, and then there are other elements that make up the sun, or make up Mars, or make up your desk or your notebook. And so what elements we put together, it determines whatever that object is, right? So that's why I mean it's kind of like a list of ingredients. And so you put different things together to make different things. It's kind of like when you're cooking and you list out all the ingredients that you could ever cook with. Well, you would put certain ingredients together to make a cake, and you would put different ingredients together to make spaghetti. So you wouldn't, use tomato sauce in your cake. That would be gross, right? It would make it something different. It wouldn't be a cake. And so that's what makes everything what it is. It's made of these elements, these atoms, and the periodic table is basically how we organize them. So the guy that organized the periodic table is named Dmitri Mendeleev, and he organized them first of all by groups or by families. And we did an activity where I had you guys organize paint chips, and paint chips are those little colored squares that you get at Lowe's or Sherwin-Williams or Walmart whenever you are trying to pick out what color of paint you want to paint your room at your house. And I had you guys organize them, and what you noticed first were the different colors. So you had a group of orange and yellow and green and purple and blue and red. And that's kind of what Dmitri Mendeleev did. He started to notice that some of these elements had stuff that they had in common. He also noticed that some of the elements were heavier than others, or that they had a larger mass than others. And that's another thing that you guys noticed about those paint chips also. You had a whole group of cards that were red, but they varied in how their shade, how dark they were. And so we organized them with the heavy ones or the darker ones at the bottom, which is what he did. He organized them so that the heavier elements, the ones with more mass, were down at the bottom, and then the lighter ones were towards the top. So Dmitri Mendeleev is the one that we say is basically like the father of the periodic table. He's the one that put it together and organized it for us. The interesting thing about him, though, is that he didn't have all the elements back then. Back then, not all the elements had been discovered, and so when he was making the periodic table, it actually had holes in it. And so there were parts where he knew, like, hey, there's something supposed to be here, but we don't know what it is. And so eventually, as time went on, even after he had passed away, we were still finding more elements. We were able to say, oh, wow, look, it fits in this little spot right here. This is the element that was missing on the periodic table. So I gave you a blank periodic table, blank in that it's not colored. So I want you to go ahead and color it like I have here. These purple elements that I have are the metalloids right here. And then over here, my yellow ones are my metals. And then my red ones are my non-metals. Okay, including hydrogen. Hydrogen is also a non-metal. So go ahead and pause the video and color in your periodic table. And we're going to break down what the properties of each of these categories are in a little while. So let's zoom in for a second on one of these squares. There's going to be kind of a different order to these things sometimes, especially when you get towards the bottom right here. But for the most part, all periodic tables, no matter who published it or who designed it, they're going to have this basic information on them. At the very top, they're going to have an atomic number. And here it's in the center on your periodic table that I'm having you color. It's actually on the corner over here, but it's the same number. And you'll notice that all the elements are in order by that atomic number. The next thing that I have is the symbol. The symbol is kind of our way of being lazy. Instead of having to write out the whole word, the name of the element, we can just use the symbol and everybody knows what you're talking about. And this is going to be universal. This is going to be the symbol for that element everywhere you go. So most of the elements have 1 or 2 letters in their symbol. Some of them have 3. But no matter what, it's only the first one that's going to be capitalized. So you'll see here for silicon, it's a capital S and a lowercase I. For the most part, the symbols are actually the first 2 letters of the actual name of the element, but for some of them, they aren't. For example, like gold is AU, and so I'm not sure where that came from, but it's probably like the Latin or Greek term for gold. Mercury is HG. Silver is AG. So it just depends on that element. Then underneath that, you have the atomic mass, which is what I was talking about when Dmitri Mendeleev realized that some of the atoms were bigger than others. That's the atomic mass that you're talking about. And then underneath that, you have the name of the element. Sometimes these two will actually be switched. The mass and the name will be switched, but it usually has that information on there for you. So here's just a couple of versions, like I was saying, of what the squares on the periodic table will look like. If you look at this one here on the bottom left, you have pretty much just what I had just shown you. Look at the atomic mass. They put 15.999. And then over here at the top, they actually had rounded that one to 16. And then in this box, it doesn't include the name. It just has the symbol. Over here on the right-hand side, they were even more precise. They went to 15.9994. And then in these boxes over here, you'll see that they switched the atomic mass and the name. So it's the opposite of what we've seen before. I encourage you to go to this website or Google the Element song. It's a really fun song and it always puts me in a good mood, and I usually play it every now and then in class just for fun. So let's talk a little bit more about how the periodic table is organized. So the first thing I want to talk about is periods on the periodic table, and it's really easy to remember how many periods there are because it's the same number of periods that we have at Memorial Junior High, right? We have 7 periods, 7 classes, and there are also 7 periods on the periodic table. And that's including these bottom ones, which are the lanthanides and the actinides, and the periodic table should be 3D. So these are kind of supposed to be kind of stuck in between here. And so those are also period 6 and period 7. And so that's an easy way to remember how many periods there are, right? Just the same as we have at Memorial Junior High. And as you're going down the periodic table, that is actually, the elements are actually increasing in size, right? They're increasing in mass. And the periods actually tell you how many rings the atom has. So you're not going to really get into that this year. You'll get into it more in 8th grade, drawing the atom and figuring out what an atom of a specific element is going to be looking like. But the period tells you how many rings that atom is going to have. And so those rings are where the electrons go. Then you also have groups. Groups are going to be vertical. And so we have 18 groups here. And they go all the way to 18 way over here. And so these are also called families. And it's really important for you to know that elements are always going to have stuff in common with their groups or their family. And so it's kind of like you and your family. You have stuff in common with each other, right? You share genes and you may look similar. Or it's like you and your group of friends. You have stuff in common. Maybe you're all in band or you all play Fortnite together. So that's important to remember about the groups and families in the periodic table. They're going to have things in common with each other. And so for your homework, I'm going to give you a periodic table where you actually have to come up with your own periodic table of whatever you want, any topic you want to, and you're going to have to come up with your 8 families that you're going to have on your periodic table. So let's talk about properties of metals first. Really, if you know the properties of metals, then you pretty much already know the other ones. Because it's kind of just an extension of that. And if you picture a piece of metal in your head right now, all of these are going to be a lot of common sense. So imagine a metal piece. Okay, that metal piece is going to be a good conductor of heat and electricity, right? That's why we use metal for wires. That's why we use metal to cook on the stove or in the oven, because it's a good conductor. It's going to be shiny or lustrous. They're usually going to be silver or gray in color. Some of them are a little yellow like gold, but most of them are going to be silver gray. They're also going to be malleable and ductile. This means that they can actually be shaped. So think of like aluminum foil. It can be hammered into sheets, or it can be stretched out into wires for your cell phone charger. Anything else that's not a metal, you're not going to be able to do that with it. Like a non-metal like carbon, right, that we use to like barbecue. Imagine trying to hammer that into a sheet or shape it into a wire. It's not going to do that, right? It's just going to crumble. And then they're also going to most of them are going to be solid at room temperature. One exception would be like mercury is liquid at room temperature. So if you remember those, then these are going to be super easy because it's just the opposite. Everything that metals are, non-metals are not. So they're going to be bad conductors, they're dull or not lustrous, not shiny, and then they're going to be brittle. In other words, they break easily. Again, imagine hammering that charcoal, okay, that carbon. It is just going to break, right? It's going to crumble, and so that's brittle. And then metalloids are basically like that friend of yours that can't figure out, you know, what they want, or they're very indecisive. They never make up their mind. That's what metalloids are like. And so they have properties of both metals and non-metals. So they can be shiny or they can be dull, and they are okay conductors. So they can conduct heat and electricity, but they're not going to be as good as metals. They'll be almost as good as metals, but they're definitely not as bad as non-metals. So they're in between good and bad. They're just kind of okay conductors. So here are a few examples. So metals, examples would be like copper, gold, sodium. This is going to be stuff that's electrical wire, right? We use copper for that. It's going to be a good conductor, so that's why we use it. Gold is in jewelry. We also have gold in computer parts. Sodium, we talked a little bit about sodium when we talked about physical and chemical changes. You can find it in agriculture, like salt licks that you might buy for a goat or livestock, because they need those mineral blocks that they lick. Non-metals would be like oxygen, which is what we breathe, chlorine, that we use to purify water. We use it in swimming pools. And then helium is found in balloons. And then a few metalloids would be like boron, silicon. There's a lot of silicon in computers also. And then arsenic is actually poisonous, so that you'll find it in poisons. So here's an example of what you are going to do for your homework when you make your periodic table. So you have to have 8 groups. I actually haven't counted this one. So this is just an example, but you have a handout that's going to go with this. And you have to make sure that they go along with whatever is in that family. So like here, these are like all the Superman characters. And so you need to make sure that whatever your family, that family is in that row, right? They have to have something in common with each other. So I've got some examples in class if you want to come in, take a look at those if you haven't been able to look at them, or if you weren't there at school when I showed them to the class. But that's going to be your homework. Thanks for watching, and let me know if you have any questions.
Thank you for visiting Somo's YouTube channel. Look for us on Facebook, Instagram, and Snapchat. And don't forget to like and subscribe.